Hello, everyone. Welcome to the last session of this bootcamp. Since we don't have a very large audience size here, so I want to make this interactive. Just feel free to raise your hand or stop me if you have any questions or concerns. Right. So in the first hour, I'm going to talk something about metadata and then give you some tips for you to manage metadata. And in the next 1 hour, Nick is going to talk something great about further and how to deposit your data into National Data Repository. My name is George Barker. I'm Data Integration Specialist working at ARC. So some land acknowledgement. We would like to acknowledge that University of British Columbia Point Grey campus is located on the traditional, ancestral, and unceded territory of the Musqueam people. University of British Columbia Okanagan campus lies on the unceded territory of the Sioux peoples. Same again, few housekeeping slides. You have been muted already when you enter the room. This webinar is being recorded. The recording for this session will be made available on ARC's website, especially on YouTube, ARC YouTube channel. All materials for the bootcamp are available in the Open Science Framework. Here's the link. Materials for this session are also available in the Open Science Framework here, and I'm going to post the link. Oh, listed that. Thank you. This is a hybrid learning environment. Virtual questions can be asked via Zoom Q&A or by raising a virtual hand. Live questions in the presenter room can be asked by raising a hand. Live questions in the non-presenter room can be asked by raising a hand, which a helper will ask the instructor through Zoom. Again, we want your feedback. Time will be given towards the end of the session to complete a very short feedback form. For those online learners, you will get a Zoom prompt. For the in-person learners, you can go to the OSF page and click on the feedback form link. Okay, so this session has 3 parts. In part A, you're going to learn what metadata is. And part 2, you will know why metadata is important. And finally, I'm going to give you some tips to help you manage your metadata. So what is metadata? This is, okay, I forgot the objective. This is single objective, so you will be able to describe what metadata is. This is the definition. Metadata is data about data. But really, that's the question I asked myself. And I don't, excuse me, I don't like this definition for mainly 2 reasons. A, this is vague. Metadata is data about data. What data are you guys talking about? And B, this is confusing, or I would say this is misleading. When someone gives you some data sets, you look at your data, you look at their data and you try to understand the structure of it, you try to understand the content of it, and finally you try to derive some summaries out of it. So that is the definition of data profiling. It's not really metadata. So I think we need something better here. But before that, I'd like to give you a little poll. All you need to do is to say which one is metadata and which one is not. A, you have some information about a book, including book title, author, language, ISBN number. And B is a snippet of XML file, which states the title for the dataset and URL to the dataset, description to this dataset, and some privacy statement, and some data columns information. C is nutrition facts of Coca-Cola. D is part of someone's report and it is content page. You have the titles, you have the page numbers, and the E. When you click on some link, you want to open a file, you want to see it, but you actually can because it's confidential. It's top secret. You don't have the privilege to see that. And F, you are adding a label to a physical sample. This label has a lab ID, sample ID, date, etc. So I will launch the poll. And I will give you 2 minutes. Cool. I'm seeing some answers coming through. The reason I do that is because some people would know metadata topic is quite dry, but it is very important. It is unsung hero. And I don't just want to introduce the concepts. And if I do concepts, you guys are going to hate it. So if you make more interactive, you may like it. Okay, another 30 minutes. Okay, right. So I think you guys have done pretty well. All of them are metadata, right? So some of them are descriptive metadata, and D is structural metadata. It gives you the structure of this report, and E is administrative metadata. So let's come back to this question. Let me get rid of this poll results. One thing we know is that we don't want this definition, or at least I don't want this definition. What is metadata? Metadata is a series of supplemental necessary information in the form of plain text, text files, documents, diagrams, images, and tabular tables that is provided along with data in order to improve data quality, accessibility, and usefulness. It is quite wordy, right? I'm going to break this down. So this definition talks about 3 things. First of all, metadata is additional information that is provided with your data, additional, supplemental. And then metadata can have various forms. It can be a text, it can be a file, text file, CSV, JSON, it can be a document, it can be schematic diagrams, especially for the data models. If you have a SQL database, it can be graphic images, it can be tables. And finally, what it does, it's gonna help improve data quality, accessibility, and usefulness. I'm gonna expand this in a minute. So before moving on to the next topic, do we have any questions? I guess so far we are good. So feel free to stop me if you have any questions once again. Then next, why metadata is important? Again, is a simple or single objective. You will know the importance of metadata. But before that, I'm gonna tell 3 real-life examples. Then hopefully that can get you, to think the importance of metadata. Number 1, NASA's very expensive mistake. In December 1998, NASA launched its Mars Climate Orbiter in order to study Martian atmosphere and climate. This is the total cost of this project, $125 million US. After almost 10 months, they arrived finally and started to lower this orbiter. But this orbiter burned up and broke into pieces when entered Mars atmosphere. People want to know what happened, especially when NASA engineers were just about to celebrate their achievement. NASA uses metric system. LMA, who is the designer and the builder of this orbiter, used imperial system, and the difference of this unit of measure was not documented. So the navigation signal sent from Earth was in Newton's power, while this orbiter responded in pounds of force. Of course, it's not gonna work. So this had caused this thruster fired incorrectly. It pushed this orbiter 69 kilometers closer to Mars, where it burned for some complicated reasons. So this is a pretty big price tag for some small effort, and we have a metadata inconsistency issue here. Number 2, UK government reported or published 2003 report on Iraq's supposed weapons of mass destruction. There's nothing wrong with this report. This report was released in Word format. You guys all know what Word document looks like. So it contains rich metadata. Someone downloaded this report, right-clicked on the properties, and he saw the people's names who contributed to the last 10 versions, as well as some other information. So that raised some flags about the quality, credibility, and authenticity of this report. As soon as UK government realized this, they replaced this Word document with PDF, since PDF contains less metadata. Number 3, US Department of Education published its 2010 annual performance report. And this is what this report looks like. And it's a nice report. So someone went to this .gov website, downloaded this report, disabled this read-only protection, which was surprisingly not password protected, and went on page 41, this one, targeted this graph, which looked normal, and then that person selected change data in the graph's context menu. All of a sudden, an embedded Excel source file popped up, which showed loads of private information. And certainly the publisher didn't want the public to read all about that, and that raised some concerns of privacy issues. Clearly, there was a breach of privacy. So I guess you guys can have some rough ideas about why metadata is important, what metadata can do. Now let's review this together. First of all, Metadata is important to help you understand your data, what your data was about, when your data was collected, and who collected it. And also it tells you the structure of your data and how the data was interpreted. And if data is stored in SQL database, you will document your data models, for example, conceptual model, logical model, physical model, messaging model, all about that. And also you need to show the relationships between the data objects in the models. And then metadata will tell you what happened to your data. Very often when your data arrives, you will do some calculations. You will derive some new parameters, and metadata is going to document what had been done to the data. Also, you would apply some QA/QC processes, and how did you do with those missing data? And for those duplicate and mismatched records, what did you do with them? So that's also metadata's job. Track data flow. We all know data continuously flows in the data pipeline since it's originated until its exhaustion. And but quite often it is a black box to most people. So we don't know what happened. And what if you have some data set or some data points which looked off? Then you want to trace back to the source of the data, that's provenance. So if you have a metadata management or proper metadata management, you would tag your data with metadata information. When there's a need, you can trace back to your source data and to find out what had been done, if that is the real case or if there are any man-made errors involved. And it's going to help you troubleshoot your data issue. And then metadata is important when you want to publish your data. When you, for example, if you want to publish your data to Further or to Dataverse, you cannot just publish your data by itself. You've got to publish your metadata as well. Otherwise, it won't let you publish your data. And then we have a data accessibility. So you could add metadata tags to your data to restrict the access. For example, if you are doing a PhD and you probably don't want your data to be released in 5 years, for example, so you can do that if you use proper metadata. Analytics. Nowadays, people use dashboards, automated reports to help visualize data. And certainly you need metadata to accompany your dashboards and your reports to help users to understand your data. Machine learning. If you know machine learning, you understand you just cannot use the raw data set. You've got to stage your data, you need to classify your data, also you need to hierarchize your data, label your data using some metadata so that your data set will be ready for your machine learning models to pick up. Explore data. Some large organizations, they use data catalogs. Data catalog is a central large repository that defines all organizations' data assets. That includes structured data and unstructured data. Examples of unstructured data include reports, image files, models, your algorithm, stuff like that. And with a data catalog, you can easily search your data asset and also track the use of your data asset. And if you want to search some data in data repository, you would use keyword, which is also metadata, to search the data set. That's data governance and data architecture. Data governance is a framework and the direction of data management. It uses policies, standards, processes to help this governance process. And there is a very important component or a pillar to support the entire data governance framework. So without metadata, this data governance is not going to work. And in modern data architecture, people use data hub, data fabric, or even data mesh. They will plug these ideas into their data architecture, and this data hub, data fabric, use metadata concept and embed metadata into the whole process. So if there's no metadata repository, there's no metadata management, there won't be a sound data architecture. And many more. I give you two examples here. CDM stands for Common Data Model. So that is something, or also a data repository, which sits between the data sources and your applications. And that is particularly important if organization has many data sources and tons of data applications, because it's gonna communicate, it's gonna facilitate communications between the data source and data applications. And how to do that? So that is being done using some metadata characteristics to group these common data together. Master data management is also a very fancy stuff, and that refers making master record of the data for a person or a thing based on some common characteristics using metadata as well. So that is very important for promoting, for example, data democratization. The meaning of that is that in organization, everyone has access to data. There's no gatekeeper at the gateway working as a bottleneck. So you may not be so familiar with master data management. I'll give you a little example here. UBC has a Workday. If you ever logged into Workday, you click on your profile and you will see who is your manager. And if you click on your manager's icon or a box, it will bring you up to the higher level. You can see the person who manages your manager, and you can go all the way up to president of UBC. So that's the example of master data management. So as you can see here, metadata really embraces the idea data is strategic asset, and it really helps attain data quality, accessibility, and something else. That's something I called AUSTC, which stands for accessibility, that's integrity, usability, security, trustedness, and compliance. So that's the importance of metadata. There are so many points, I couldn't list them all out. So any questions? Okay, I'll move on. 4 tips for metadata management. In this section, you will get some ideas about naming your files, organizing your folders, describing your data sets, and finally, you will learn something about metadata standard, and then you will know how to choose the right standard for your own research. tip number 1, name your files properly. We all know file naming is pretty arbitrary. And the general guidance is to keep it short, descriptive, and consistent. You will use combinations of letters and numbers if needed. You will avoid special characters. Spaces are tricky, and it is argued that spaces should be avoided in file names, even though the modern operating system can handle file names with spaces. And some people said there's no legitimate reasons why spaces should be avoided. So what we're gonna do? It's your call. But if you are a programmer, or if you want to be a programmer, you probably don't want to include spaces in your file names, in your script file names. Why? Because Python imports and Java script files work better without spaces. And also, if you have a file names without spaces, sometimes they can be more friendly in command line environment. So I would suggest you considering this format when you name your file, starting with description, followed by date, and then additional info. You can connect them by underscore or dash. For description, it should be short. For example, you probably want to use SOP instead of standard operating procedure. You want to use the camel cases, which is a combination of upper and lower cases to avoid spaces. Here's example. For the date, you want to stick with ISO standard for the date format. That is in 4-digit year, 2-digit month, and 2-digit date. You can put bunch of information in this additional component. For example, you may want to include the author, include the version number, and so on. I'll give you some examples here. Say, if you are the one who is going to handle all of the data requests from outside or inside organization. So you may find it's useful to create a little processing document that standardizes the way such request is handled. If I'm naming this file, I would say something like standard operating procedure number 4, because I have SOP for other stuff, and that is for data access. This one, archival area. You have your data collected regularly or at one time, and you put your data in a temporary storage. And then you have your JavaScript, which will go inside the temporary storage and archive your data. So if everything goes okay, and the data just gets archived quietly, you wouldn't even notice. And then when you go to your temporary storage, and you will see all of your data had gone. So that's what it's supposed to do. But what if there is a connection issue or other problems? You want to receive a notification for that. So in the JavaScript, I say something like, when there is a connection issue, or whenever my data cannot be archived, I want to receive an error message that is in XML format with the date this error actually occurred. That's what this file name means. And this one, okay, that stands for data mapping. and this is the name of an instrument which which measures carbon dioxide concentration in water. Say you have multiple devices. They collect all sorts of data, and the data is stored in SQL database. Different end users will have a different need of the data format based on the device or the instrument. Say person A may want data in MATLAB file, and person B may want their data in JSON file, and person C wants the data in image file. So to meet their need, you develop another JavaScript to convert all of the tabular data, which is in the database, to all possible data product, CSV file, MATLAB file, image file, a JSON file, for example. So what you need to do here is to create a SQL script to map the data for specific device to specific data product. So that's what it says here. So I want to map data product for this ProOceanus device. And this is SQL script. This script had been tested in QA environment, and now it's ready to be run in the production environment. And this one is a nanopore sequencing data file from analysis of DNA or RNA fragments. CHM is the consortium code, followed by sample name, sample number, flow cell lane number, followed by index number. And this is a FASTQ file, and it is compressed. So that's the way I want to name it. And this one is a PowerPoint presentation file. And we did that because we are going to do a faculty roadshow. And this presentation was made on this date, done by Nick Rockland. This is the first version. You noticed I include a leading 0 here because I may need we may need a 10th version, who knows, but it's quite okay to skip this 0. And I made some comments. The final one is a meeting note, and the meeting is a research data management strategy meeting that happened on this date. So that's tip 1, naming your files. Tip number 2, organize your folders. Again, folder organization is pretty arbitrary too. And the general guidance is to minimize the number of your folders. You want to organize your folders logically, systematically, and consistently. Since it is arbitrary, I'm not going to tell you what to do, but to tell you what you do not want to do. You want to avoid mass dumping. That means you throw everything in one folder or 2 or 3 folders, and then they get really messy because you want stuff to be hierarchical. You want everything structured, so you want to avoid mass dumping. You don't want to nest too many folders in one folder. The reason of that is A, it takes a lot of clicks, right? And B, and you may hit the limit of path limitation. If you're using Windows operating system, 256 characters is the limit. That includes the path and the file name too. And then you want to avoid the special characters. You don't want to use your download folders as a permanent place to store your stuff. It's meant to be used for temporary use only. And you don't want to store your folders or your stuff on your desktop because the desktop is meant to be, clean and showing some nice background rather than those folder icons or file icons. And with time, you may have problems finding your file. So let's see some examples. In this example, this person has 3 L0 level folders. That's education, work, personal. This person used these folders to separate the education and employment and the personal life. In education, there are 3 subfolders because this person did 3 degrees. And he worked at SFU before, and now he's at UBC. So that's why you see 2 subfolders on the work folder. In the personal folder, there are a lot more stuff. The resume goes to this resume folder. In this professional development folder, he will put some like training and learning stuff in it. Vacations are important. It gets its own folder, and so on. And then if you expand this education folder and then expand this master's folder, you get to see 6 subfolders. All of the HR stuff can go to this admin folder. Courses folder will have many subfolders for every for each of the courses. Thesis is important. It gets its own folder because you will have a lot of stuff in this folder. All of your PDF references can go to this folder, and you have conferences and meetings folder. This is example of nesting too many folders, and this is not good. You want to avoid this. Tip number 3, describe your data sets. Why you want to describe your data sets? Say you are the person who collected this data, who created this data set. You know everything about your data, but your colleagues, your project partners, and other data users, they may not have the same knowledge as you do. So to help them understand your data set better, or if you don't want to receive random emails from them, you'd better create a data set description file. And say you know your data very well today, but do you really know that 100% in 6 months time? What about in a year? So to have a little description for your data set is also good for future self. And how to do that? It's easy. Just make a README file. I would encourage you to consider these basic elements when drafting a README file. You want to have a title to describe your data set. Use plain language. You want to have a description to describe your project briefly, as well as your data assets, including your variables, unit of measure, any QA/QC applied to your data set, and so on. You want to have some keywords. You want to show when the last modification date was, and your name and your contact info, as well as some license information. So in this example, you see this is the title of this data set. That's mooring data collected at Saanich Inlet between 2020 and 2021. Mooring just means a collection of instrument anchored on the seafloor. And then there's description, 2 deployments made during this time, and I have some variables here. This is the unit of measure. Unfortunately, there's no any QA/QC done for the data set. And I also provide the DOI. This is a pseudo DOI, so don't try to Google that because you wouldn't get anything. And I have my keywords. modification date, contact, and license info. Okay, tip number 4, choose the right metadata standard. What is a metadata standard? Metadata standard is a document that standardizes the way data is described and structured. In research data management, people use that as a guide document to help draft metadata records or metadata files as part of data publishing process. What does a metadata standard looks like? It looks like this. And it documents some elements you need to include in your metadata record. And also it explains these elements and also gives some examples. Why we need a metadata standard? Well, as it says here, you've got to have that if you want to publish your data to a data repository. Without that, it wouldn't let you do it. There are many metadata standards based on disciplines. If you are doing social science or economic science, you would go for DDI. This one, Dublin Core, is generic standard. That means you can apply that to all disciplines. For example, if you are doing biology, you can go for Darwin Core or go to this DC. So the next question, which standard should I use? And there is a good document or good web page that lists all existing metadata standards grouped by discipline. Don't worry about writing it down because I have the link in one of the slides. You will see in a minute. This is example of finalized or completed metadata record that is in XML format. In this example, don't worry about the content. I'm just showing you the building blocks of this XML file. It has the title describing the data set. It has the URL pointing to the location of the data set. It has the description, privacy statement, as well as some data column information. So as soon as you did your metadata file or you convert it to XML format, it would look something like this. Questions? Okay. So here's our conclusion. Metadata, what is metadata? Metadata is the additional information provided with your data in order to improve data quality, usefulness. And metadata is critical to help attain data AUSTC. Again, I named it. If you don't like it, it's fine. That stands for accessibility, integrity, usability, security, trustness, and compliance. File naming. You want to name your files short, and it should be descriptive, and the file name should be consistent. You want to use combinations of letters and numbers when possible, and you want to use camel cases if you want to avoid spaces. Photo organization should be logical, strategic, and consistent. Remember those don'ts I have on the earlier slides. Dataset description. All you need to do is to create a little README file, and you want to include some basic elements in this README file. And I want to say here, it's not only limited to those basic elements, and you can have your own, but that's just the way I do it. And finally, metadata standard. Metadata standard is needed and especially when you want to publish your data, when you prepare your metadata document. And there are many standards based on disciplines. This is the data journey, origination to exhaustion. When data comes in this black box, and then it goes to the final stage. The end of data journey could be the beginning of another journey, and so on and so forth. How to make your data journey smooth. Metadata for the win. So good luck with your data journey and good luck with your research. And here's the useful resource slides. And thank you. So we have just about 10 minutes before I'll pass it over to Nick, and I can take questions if there's any. Jeff, I know you are one of the experts of RDM, so I would love to hear your voice.
You're right on it. That was amazing. That was really good, George. What I liked most about this presentation were the examples that you provided throughout. And I'm not sure what the likelihood of AIUST becoming like FAIR or CARE or one of these other principles. Yes. I think it would benefit from actually saying something or spelling something.
Yeah,
that was really good.
You're right. You're right. Often people use FAIR principle. For those who are not familiar with that, FAIR stands for findable, accessible, interoperable, and reusable. So that is for improving data sharing and also, again, data usefulness when you want to share your data with your colleagues. I know when I decided to use that acronym, I was prepared to hear some negative voice.
That's not negative. It's just an observation. Anyway, I don't know. I mean, I may have missed it, but was there any mention of good metadata making data more usable in the sense of machine actionability? If you have good metadata, you can actually use the metadata to let the machines talk to each other and share the data and all that kind of stuff.
Yeah, that is something this CDM does. And this is an advanced thing, this one. So this is just example. So it is okay if you don't have too many data sources, say less than 10, it is okay. Say, so data sources means, you know this can be in one database or can be in one enterprise resource planning place, or in another storage, object storage, and you don't have too many applications, right? Then if you draw a logical one-to-one relationship, you will have less messy diagram, because this one-to-one relationship, you can imagine one application points to two data sources, and you have another application pointing to three sources. But imagine if you have, hundreds of databases and even hundreds of applications, is going to be a problem. And the beauty of having CDM is to have that sitting in the middle of these two layers. And all they need to do, all the machine needs to do, is to talk to this model, common data model or common data definition, and it doesn't have to worry about the compatibility and accessibility of this data thing. And so it's gonna just make machine happier when it wants to communicate with data stored in different sources. So that's one example. But I couldn't go deep here because I'm sure people will get lost, and because it's pretty a complex thing. And I was thinking about another example for machine readable process.
Well, you're thinking about, could you comment on the importance of metadata, and in particular in metadata standards in just encouraging and facilitating the discovery of your data? If you've gone to all the trouble of gathering and documenting your data, having it discovered, reused, and getting some credit back is important. How does metadata standards facilitate that?
Okay, I think about it. Nick, feel free to jump in. Okay, could you, Jeff, expand a little bit one more time?
So the kinds of things that I'm thinking about here are, if data in your discipline, it adopts or has generally used a particular standard, so be it DDI in the social sciences or something else in the biological sciences, it is likely that the repositories that would house your data will be friendly with that metadata standard, and that the discovery tools that are built to expose your data to a broader audience by way of search engines and so on would leverage that standard metadata in order to up the click-throughs to your data set. People are going to find it because your metadata is rich. People are going to understand it and be encouraged to go back and use your data. And the term I've heard, and it's not my term, it's from a European context, the reputation economy for researchers is built on people looking at using their academic articles, but also hopefully and increasingly using and reusing their data. Good to see your face again, Nick. What a week, eh?
Oh, what a week. Yeah, sorry, I was just getting some water, but it sounds like you guys were having a pretty fun discussion while I stepped out on the break.
Yeah, I was asking George about the importance of applying appropriate metadata standards in terms of facilitating discovery down the road. It's a love note to your future self if you want to reuse the data, but it's also improving discoverability in a pretty meaningful way.
Right. So, yeah, I think, Jeff, you're talking about a you know, in how can I put it? In research field, right? Especially when you share data with someone, how this metadata standard can facilitate machine readable actions and to improve data sharing.
Yeah, I mean, a very simple non-machine actionable kind of example is one where if you've named your variables, variable 1, var1, var2, var3, var4, and if there's a better way of describing that's actually descriptive, then some search tools will allow data sets to be searched to the variable level, and your data set will then be exposed. Because and this is a simple example, if your data set has something on smoking and something on asthma, and you want to find all the data sets out there that have both smoking and asthma as elements within that data set for analysis, if you've named it var1, var2, var3, and it's not very well described and so on, that data set will never show the light of day in any search.
Exactly. That reminds me, a few years ago, I was doing some search in Dataverse, and I was typing some words specifically, but I couldn't get any hit, and I was so frustrated. So I guess that's one of the reasons, or could be one of the reasons, right? People use var1, var2, var3.
And the same is true with looking for things by dates, looking for things by, the appropriate units of measurement and so on. It's just yeah, you're doing yourself and everybody else a favor.
Mm-hmm. Okay, so I have a comment here. So can you read the poll to the people in the room? Yes, so let me find out the poll. And let me see if I can reshare my screen and just use the last 1 or 2 minutes. Share. Okay, you guys can see the poll results, can you? And the second one is pretty good. XML file is definitely a metadata. And let me bring to the first page.
I wasn't seeing the poll.
Oh, I need to reshare this.
Yeah, George, I also can't see the poll.
Yeah, got it. Okay, so I have this with me now. So I'll stop share and then I'll reshare. Share screen. Okay, you can see it now. Okay, cool.
I can't see the poll. I can see the slide.
Only the slide, not the poll.
No, not the poll.
Let me share poll specifically.
I don't know if other people could see the poll, but I'm just giving you my view.
Right.
I could not. Still no poll.
Mm-hmm. Interesting. Let me just copy this poll to one of the slides because it's I think it's important for people to see the poll result.
Oh, hold on, George. We can see that now.
You can see that now.
Yeah.
Which one you can see? You can see 1 or 2 polls, just one.
You can take. I can see your snipping tool. So if you minimize
snipping
that.
tool. That is good. Okay. So the first one is 80% people got it right. So that is a metadata for a book. So when you want to buy a book on Amazon, you will search the book, you will read the book title and the author and maybe abstract. That's metadata. And the next one, XML file, certainly that is a metadata because that is added for a publishing data set. Nutrient fact, yes, this is very interesting. and this, yeah, that is metadata too. And this one, report content, so that's structural metadata. So when in your thesis or in your report, you will write a content section and you may not notice that, but that is metadata too. And this one is not showing up very well. I will get another screen grab. Where's the poll? It's here. Okay.
Hey, George, just for time's sake, do you think we could get to the next presentation?
Yeah, just 1 minute. Is that okay? Can you see it? My snipping tool.
I can. It's the snipping tool we saw before.
All right. Okay. Never mind. And I just read it through. So and then the for the confidentiality, and 60% of people said no, that is not metadata. I know this is confusing, but it does restrict the access of a data file that is metadata. And the F sample labels, and 80% of people got it correct. It is metadata. It's a perfect example of metadata describing what data is and what your physical sample is. So Nick, sorry for running a extra few minutes. I hand it over to you now.
All right, no worries, George. Thanks for that wonderful presentation. So let me just jump in here. Share my screen. I'm going to share the screen, but so if I view, no, I want to jump into slideshow. Oh, not from presenter view. All right, can people see my slides?
Yes, we can.
Okay, awesome. Thanks, Jerry. And thank you all. Friday afternoon, long weekend. You are all soldiers, and it's really nice to see this cohort who has stuck through this entire week. It's been a bit of a slog, but it's really much appreciated for you all to come out for this. And so now that George has kind of primed the pump with this intro on metadata, we're actually going to get into depositing data using FRDR and moving some data that we had on Chinook to FRDR after going through a bit of an intro. So jumping right into things, the overview for this session, I'm going to do a brief introduction on data repositories, talk about what they are, the types of options that you have, and then I'll move over to an introduction to FRDR, which is the Federated Research Data Repository. It is a national data repository, and go through a demo that we can walk through to depositing data. And you see here, I have an asterisk next to data discovery with FRDR. There is kind of a little bonus round, but Friday afternoon, I'm anticipating not everybody wants to stick around for that. There is some slides shared that you can poke around with. If you have any questions, happy to answer them, but I don't think that we're going to get to that today. Cool, let's get into it. So, introduction to data repositories. The section objectives, not the session objectives. I'm going to start off by explaining the concept of data repositories, how they apply to your research, where they fit into this whole cycle. And then I'm going to identify a few different options. We'll talk about Borealis, which is an instance that UBC has, but it's also an instance that's across Canada for data repositories at specific institutions. I'll talk briefly about the RE3 data repository searcher, which is effectively a website where you can search for discipline-specific repositories. And then I'll finish by talking about Circle, which is not a data repository, but absolutely plays a role in this ecosystem. So talking about what is a data repository and going back right to one of those first sections that we have and this data lifecycle where you start off with this plan, you go and create and process, analyze your data. Data repositories are really playing a role in these last three phases, where it's a place for you to deposit and preserve your data. You can share it with other people where they can then discover it and reuse their data. Now, one thing that is worth mentioning here, when you're thinking that data repositories play a role in this preservation, the sharing, and reuse, the things that you do in the planning, the creation, processing, and the analysis, they all play a role in how your data looks at this point. And if you're dealing with any type of ethics review, you really need to build this plan into that review, because if you don't get the consent to do this, you don't build it into your ethics application, you might not be able to deposit your data. As you're going through creating, processing, moving, and cleaning your data, if things really fall apart and it's not documented well, and maybe your processes aren't reproducible, then you're really not giving people much to work with here. And so as you go through your active data lifecycle, which we've spent all week going through, it's worthwhile thinking how to keep these processes reproducible, transparent, so when you get to the end of your project, you are able to deposit data that's useful and has value in the long term. And so talking about what is a data repository, these are systems that facilitate the deposit, sharing, preservation, and finding of research data. They increase the transparency of research. As George was talking about, there are some horror shows when you don't get that transparency of research, or people aren't documenting their work correctly. There's a lot of studies that have to be retracted because they weren't transparent with their data. They might have been falsified, or they just might not have done the proper protocols for it. So it's about that. And then when people are sharing their data, it allows research discoveries to accelerate. People can build upon additional studies. They can work together rather than having to recreate something from scratch every time they go for a project. And then also the meeting of funder requirements. And so just circling back to something that was brought up earlier here, this tri-agency RDM policy requiring a DMP starting this fall, but this upcoming requirement to begin depositing research data, metadata, and code into a digital repository. As mentioned, and if you weren't there for the earlier sessions, there is no date on this yet, but the building of infrastructure, the capacity to support this is what the tri-agency is waiting upon, and we're getting there. And in Canada, we are a little bit late to this race. That Europe, the States, Australia, they are more advanced in this area than us. So if you are working on international grants, it's possible that you might be required to do these type of things. And so kicking off to the types of options that we have for data repositories in Canada. The first one is Borealis. Now, these servers are housed at the University of Toronto, but there are instances all across Canada. Now, all data that you deposit into Borealis can be made publicly available. There's granular access controls, so you can choose who gets to see what. If you want to make things private for now, you can refrain from publishing that right away. As part of the Borealis tool, there's a visualization tool to explore data sets as you go on to discover them, harking back to the conversation that Jeff and George were having about the discovery of data. So this is a really great tool to do that. Another great thing is it does mint DOIs, otherwise known as digital object identifiers, which gives your data set a long-term persistent identifier, so it can be found. It's not going to go away like some website where you get a dead URL. Now, as mentioned, there's servers at U of T, but there's approximately 50 Canadian institutions with unique instances. UBC does have their own Borealis, so it's our institutional data repository. We offer support for depositing data sets into it, and there is archival preservation as well that's wrapped up with this tool. Now, going into some of the specifics of it, there is a 3 GB individual file limit for this, recommendation of 500 megabytes for tabular data. As you can see here, there's an asterisk next to this next one. It only accepts de-identified or non-confidential data sets. Our level of curation is, data curation is something that we're trying to grow in Canada, where you deposit your data, someone is able to look at what you deposited and ensure that it meets X, Y, and Z criteria. We're trying to build up this kind of checking for de-identification, but this isn't something that we're very advanced with either in Canada or at UBC. And so when we talk about de-identification, if you're interested in what this looks like, if you can do this, reach out to us, talk to the library, and they will kind of help walk you through this in terms of what you can expect and do with this. You are able to set up metadata only records for sensitive data. So if you're not actually able to deposit your data because it is sensitive, you can deposit a record into Borealis. And so people can find this record, they can know that your data set exists. And if it is something that they're interested in, they can contact you, work it out with ethics, and possibly access that data set if it's something that you're able to share with them and that they're able to use in a research landscape that matches with any type of ethics protocols that they would need to go through. And then finally, you can set up embargo periods. So if there is some sort of embargo that you want to deposit your data now, but you can't make it freely available for a year or two, Borealis absolutely accompanies that. Now, I did mention that, and I think Jeff and George were talking about it. I came in kind of the middle of that conversation, but in addition to these general repositories, there are discipline-specific repositories, and it's not it's very different across disciplines, that some disciplines really have a practice of using ones that aren't general and very specific ones. Other disciplines are cool with the general aspect of it. This re3data.org, which the link to, sorry, both Borealis and this can be found in the OSF. It's a directory of repositories by subject, country, and content type. This can be used as a tool to both find repositories for your subject if you want to deposit in there. But if you're also just looking for data sets and you want to kind of whittle it down and see if there are any discipline-specific repositories that you can search through, this is a great tool to go through as well. And then last but not least, Circle. And so this is a digital repository, and being very clear, this is not a data repository, but this is something that we have at UBC, and it's a repository to house research and teaching materials created by UBC community and partners. Now, the use case for this is we're talking about sharing data, but the sharing of all the other materials with your work can be tremendously important as well. And, you know, with the requirements to make some things open access, not all journals allow that type of thing to happen. And sometimes they might make it open access a year or two after it's published. But in Circle, you can actually, before you get your paper published, you can put in a preprint here. So people are able to access your work before it's even published. You can share it widely and it's not behind that paywall. If you're creating other materials that have to do with projects, this can house a lot of things like that. It's also good for master's or PhD dissertations and theses. And I'd really encourage you to check this out. And I think this whole landscape that we're talking about is just sharing information that people are creating and creating an ecosystem where people can collaborate and ideas can be openly accessed and built upon. And so while we're really focusing on data here, the other materials, including publications, are absolutely part of this ecosystem. So I'm going to take a small pause here. Are there any questions? Oh, any questions about anything I've said here? No, people are chilling. Friday, just want to get over with. All right, I can keep plowing forward then. Could someone unmute in the live room, or am I just hearing movement for the first time? Okay, very cool. I will accept that as cool. All right, so jumping into FRDR and depositing data. Now, this section, I will introduce the Federated Research Data Repository, otherwise known as FRDR, and then we can do a hands-on walkthrough of depositing data into FRDR, and yeah, be on our merry way. And so FRDR is a national platform for Canadian researchers to discover, share, and preserve their research data. Now, any eligible researchers at Canadian institutions can apply for accounts. Eligible researchers, in this case, it's similar to how UBC defines them, as well as Compute Canada. So you do have to have a faculty appointment and the ability to hold funds. If you are a grad student or someone who isn't meeting these eligibility criteria, you can have someone who does apply for an account and grant you access, and then you can use it as well. It accepts large individual files and large collections of files. You get a default of 1 terabyte of storage per researcher. So earlier when I was talking about Borealis as our institutional repository, it's a great option, but we've been talking about ARC infrastructure all week, and oftentimes the data is too big to transfer into Borealis. And so this is really why FRDR is a great option and the gap that it's aiming to fill. It also offers the same type of embargoes that Borealis has, up to 2 years, as well as archival preservation. Now, it's really working to fill this gap in Canada as the single platform for data to be ingested, curated, preserved, and discovered. And so while you can deposit data natively into FRDR, so it is there, the discovery layer that FRDR has for you to search for data, which will soon be named Lunaris, so they're going through rebranding, It searches more than just the data that's in FRDR, that it searches, I think, over 100 different data repositories across Canada, including all of the instances of Dataverse, as well as a number of governmental and other research or discipline-specific repositories as well. So it's really bringing everything together and approaching that federated model. Now, got to stop and talk about this picture. Dr. Fill in the gap, fill in the gap. This is next level meaning. And just, you know, it's Friday afternoon. I'm by myself in a boardroom. The little things that keep people going. All right, so really talking about filling that gap and iterating what I just said, large files and data sets. And the way that FRDR is able to accomplish this is by working with Globus. Now, we had that Globus section this morning. I'm not sure if everybody was there. But Globus, if you are unfamiliar, is a nonprofit developed at the University of Chicago and the Argonne National Library, and it supports high-performance data transfers. You can use both the web browser, command line interfaces, and encrypted data transfers. And again, it specializes in large data transfers. So if you are dealing with ARC infrastructures, be it Sockeye, Compute Canada, your own lab servers, you can transfer the data directly from them using Globus into FRDR. And so talking briefly about what should you deposit. Now, this can be a bit of a complicated thing because, you know, when you spend a lot of time making your data and making your project, it might be tempting to deposit everything that you've produced right into this repository. Not everything that you produce is useful. And so it's worth kind of weeding things out and figuring out, you know, what would other people find value in? Now, earlier this week, we kind of talked about what types of data or files that you might have with your projects. We had this sort of list of ones that you might have. When you're thinking of what you should deposit, it's really these three categories you want to deposit. That your metadata, as George mentioned, you want things well described. People need to know what they're looking at, or else it's just, it's not very useful. The scripts or codes, how did you do your analysis? And being sure to document your script, that embedded, that commented code. If people don't really understand what's going on with your code and script, again, it can be really hard for them to reuse your data. That transparency isn't always there. And again, like, what's the utility in depositing things that others can't use? And then your final results. And you know, wanting to be clear, like, which final results should you share? Is it only the ones that supported certain research questions or certain aspects of your research? And it's ultimately up to you. But just being very clear that you don't need to deposit everything. Where do people find value in things? And doing a bit of a curation process yourself before you go to deposit. Now, as George mentioned, README files have all of these. I'm not going to cover this in too much detail, but it is great just to have some documentation when people go in. What are they looking at? How can they sort through the files, especially if there are hundreds or thousands of files? And how did you name them? What are they looking at? What is the relationship between them, if there are any? Now, if you do want to create a data dictionary or a code book that's separate from your README, you don't always have to, but it's potentially useful to include these type of things, just describing your data types, the units, how the levels of your variables work if they are categorical, or if there's variable levels, and just you want to describe what your variables are, because people might not always know. And this goes back to that metadata standard, that if you can standardize the way in which your project data is structured, it's really valuable, not only for people for that searching and discovering that Jeff and George were talking about, but if you have multiple projects that have been investigating the same type of thing and they're all structured in the same way, you can get a lot of value out of cross-analyzing those and really building up a larger data set from those. Quick aside, Stats Canada, they have a tremendous amount of data and they structure them in ways that are different than basically all other research data. And it's a huge pain for people to process and clean those up after the fact to match data that might be following metadata standards. Quick thing on file formats. It's nice to deposit files that aren't married to proprietary formats. And so these are the UBC recommendations for specific file formats that can be deposited. They're not proprietary, very open. They can be opened by anybody with regardless of the software or operating system. Considerations for this is that if you are working with proprietary software, taking a look at the beginning, what software, how you might be able to convert your files after the project's completion. And if you're unable to do that, then, you know, sometimes it's just the way it is, right? Like the focus should be getting your research done. But if there is a way that you can convert your files to these non-proprietary formats after the project's completion, thinking about how to do this at the beginning and what might enable that, it can be extremely valuable. Also worth discussing here is the compression of files. That when you are dealing with ARC infrastructure, you might have a lot of files, and you know, you do have that 1 terabyte default allocation with FRDR. I think there's some flex in that. If you talk to the FRDR folks, they're quite nice. They might boost it up, but they'll want to make sure that you are using your space efficiently. So if you want to take your files and then zip them to compress them, you want to create a tarball and compress them that way. There's a few other options that you might have. That's definitely something you should think about when you go to that deposit stage. All right, and so we've made it. I'm going to walk us through a live demo, and you can follow through with me. I practiced this a couple of times just to see how it works. It's a little buggy, and so there's going to be an error, but I think we can make our way through this. So I'm going to get out of the slideshow and jump into the screen. Can people see the OSF screen? I know there were some issues with that earlier in the week. Okay, so here, let me drop this link in the chat if people don't have it. For people in the live room, is the OSF link written on the board, or is there some way that you can quickly access that, or should I hand
It had been added already.
To the live room, George?
To the live room.
Yeah.
Okay.
No. Yeah, yeah. This is a Jerry, Jeff, Liz.
It's good.
Okay, it's on the board. They're covered. Okay, so you see we got the useful links here. We are going to click on the FRDR demo server. Boom. Let me get this out of my corner, minimize this. You don't need to see my face. I don't either. All right, so this is FRDR. Now, before jumping into the deposit data, this is the interface where you would search for data. They have some great help pages, some documentation to walk you through this, about how you would set up an account, other information as well. But for the purposes of this, we are going to deposit data. And so in order to do that, we're going to go down to this right-hand side on the deposit data. I'm going to count to 5 in my head, maybe 10, just to give people a chance to catch up so we can all do this together. And then we can jump in. 5, 2, 1, boom. People are behind. Please let me know, and I can slow down. Move this. All right. And so if you were in the Globus section earlier, this is asking for your Globus credentials. We're at the UBC, University of British Columbia, but there is a huge list. So if you get to that UBC, you can just click continue. It's going to give a CWL authentication. I think everybody has one of those. So if you get prompted for that, you can hit that login. Duo push, because that's just what they do. All right, where is this? All right, and it's accepted my duo push and bad request. Bad request. Okay, yeah. So I said that this was going to be a bit buggy, but that's okay, because if you do get a bad request, let's go back to that demo page. And if you click deposit data again, it should work. I don't know where that bug is. Jeff, I don't know if you can speak to why that happens, but if I do this again, it allows for me to submit a data set there. Yeah, okay, mystery. Anyways, so we are going to submit a data set, and this is a demo server, so everyone should have access to it. And we can click here to submit a new data set. All right, I'll give everyone a second to catch up. Anyone falling behind, or are we good? Okay, silence suggests we're good. And so you can see here, this is the default storage group. Again, this is a demo server. If there were other storage groups that you could deposit in, they might be available here. We're not going to worry about that for the sake of what we're doing here. So we can just plow forward, press continue. And then waiting, always waiting. All right, and so you can see here, these are the steps that we're going to walk through. The first is terms of use. There's always the terms of use. Feel free to read them, the terms of use and the privacy policy. It's all fairly straightforward. I'm not going to go through that, but you know, some people like to read those things. I accept. All right, so the first option they give you is to add collaborators. And so if you are working with people either at your institution, at other institution, this is a stage that you can add collaborators. And you can see here the permissions. They can edit the metadata, they can add or remove files, they can submit data sets. This is the granular access that you can provide to people. It'll depend on who you're working with. And so you can just kind of play around with that as you see fit. For the sake of this, I'm just going to keep going, but you can see there is another invite button, so you can keep inviting new collaborators and editing the permissions that they have. All right, so now we're getting into the metadata field, and these are the metadata that are required. The first, you need a title for this. I'm just going to call it ARC Bootcamp for obvious reasons. And then they want to give a description of this. Now, if you are working with an actual research project, this would probably be something like an abstract for the project that it's associated with. But you can kind of add any type of description you want for this. I am just going to add test. For keywords. Now, these keywords very much plug into how people will discover your work. I'm not going to go into controlled vocabularies or actual like library related search terms here, but it's really worth considering those and either, don't say either, go speak to your librarian. If this is something you're doing, figure out what your disciplinary keywords might be, because it really does enhance the discoverability of your data set for the people who would be looking for it. I'm just going to write test here because what's going on here? Oh, trackpad, not going well. But noting that test asterisks, don't write that, but you can get a sense of what I'm trying to say here. Now, going down, it does give you the field of research for grouping, so people can search your specific data sets by subject, and it gets quite granular. So starting off with this group field, you can choose your group, and you can see that it gets pretty extensive in terms of what you want to do. In terms of what I'm going to pick, maybe I'm feeling philosophical today. So I'm just going to say philosophy. Now, once you choose your top group, and feel free to play around with the disciplines that you are related to, you can get into your classes. Philosophy, except philosophy of specific fields. Why not? Friday, you can play around with things. And then last but not least, you can drill down into your field. Why not? Yeah, I can be logical today. Why not? And you do have the option to add more if that's something you want to do. Plowing forward with this, author, last names, first names, and then your affiliation. So not UBC Properties Trust, probably just the University of British Columbia. But you can see there, I just entered UBC and it started auto-populating, giving some choices of possible affiliations I might have. And so that works not only with UBC, but of a lot of institutional groups across Canada. Now, if you do have an ORCID ID, you can put it in there. You can start connecting this to your publications, creating this network of different kind of web presence and resources, materials that you published. I have one, but I actually can't remember the number, so I'm just not going to write it down. And then the license. We haven't spent a lot of time talking about data licenses, but it's definitely something to consider. Now, the first two they kind of give you by default are they're all Creative Commons. The CC0 is just public domain. That's you throwing out information to the world, allowing people to do whatever they want with it and give you no credit for it. If you want to do that, that's totally awesome. I think most people choose this CC BY 4.0, which is allowing people to do whatever they want with their material, but they have to cite that you or the creator of this, and they also have to mention if they've made any alterations, and if so, what they are. But you can see these are not the only licenses that it allows you to slap on it. There's a few more here. As you can see, they all have links to them if you're interested in the types of licenses that you might put on your data. For me, I'm feeling generous today. I'm just going to throw my work out into the public domain. See how it happens. So plowing forward with this, now we're getting into the recommended metadata. And so the first is this date field. Maybe you started your project last year in October, and you finished today on the 7th. It was a year long. And the same for the collection period. Maybe you started a year ago. Oh, that didn't work. Calendars, mouse, tough. All right. And then your collection period, it lasted for maybe just a few months. And so the time period of your study, as well as the collection period, you can see here that you can start listing any type of funding, award numbers, your award titles. And so this is really getting into that metadata for people to discover, but also if they find your project, getting some more details about it. Adding collaborators and contributors. And so you can see here that there are a number of different fields that you can ask: a collector, manager, project manager, group sponsor, supervisor, and other. And you can see you can keep adding more as you see fit. Related identifiers. And so this is really building up a network of relations for materials part of your research project or projects. And so you can say this data set is cited by, it cites, it's supplemented to, and so it can really be related to a lot of different papers, projects, things like that. And so you can start adding this and then adding any notes that you might have about how that works. Are there any questions about this? I realize I'm kind of ripping through things, but I am happy to always answer questions. Doesn't look like there are any. Oh.
Well, good so far.
Okay, thank you, George. All right, so plowing forward with continue. This is the geographic metadata. Now, if we were going to play around with data discovery, which we're not, part of FRDR's discovery layer is something called Geodesy. And it allows for map-based searching based on geographic points as well as bounding boxes. And so if you are, as an example, an ecologist studying a specific type of invasive species in a region, you can actually look for data sets by region using map-based searching. And so adding this geographical metadata, if it's relevant to your work, it can be really valuable. And so you can see that you can do it by place name, country, province, city. And the way that Geodesy works is that it tracks those things. But you can also do it by specific geographic points with latitude and longitude, or you can make a geographic bounding box where you give each longitude kind of these points in a box and you can create your own box. Now, if this kind of thing is important to you, but you're not exactly sure how that works, if you go into Google Maps and just click on a location, it'll actually provide you the latitude and longitude for the location, so you can get this information from there, put it in here, and to build your own geographic points or bounding boxes if that is important to you. All right, getting on to the access, close to the end. So contact name, Nick Rockland, and I'm just going to jot in my email. Some access things. Questions about this. And so if you would like to put an embargo date on your data, you have the ability to. They do want a reason for embargo, and they have a curator to look at the validity of that. I'm not going to get into that right now, but if that is something you're interested in doing or that is relevant to your work, you do have that freedom. Metadata access, how can people do this? And so if you do want to create an embargo, you can still make certain parts of what you're depositing viewable. So people can search and view it. Maybe it's viewable only with a link, only viewable to you. So again, giving a bit more granularity in how this is accessed and works with that embargo period. This is always a fun question. long-term preservation. Do you intend for this data set to be preserved for 10 years? I think a lot of people, when they think of their work, they say, yeah, for sure, this is definitely going to be valuable in 10 years. Not all research is. And I'm not trying to be dismissive of anything. I think all the research that's published, it's great to see that knowledge being produced. But certain research does have a shorter shelf life than others. So it's worth thinking about whether you think this data set is worth the resources to be preserved for over 10 years, maybe adding some details about that. And then FRDR does give you that option, which is great. But if you think maybe it's only going to be valuable up until 10 years, it's equally as valuable as well. Plowing forward, I think we're almost there. Hey, we can actually transfer data now. We made it. So you do have two options here. Oh, stopping myself. You can see they're talking about READMEs here. They provide you a template if you're interested in it. In the useful links, I also provided a guide to writing README files. The template that FRDR provides is great, but yes, document your work. You can just do a drag and drop, or you can click and start. This is just my desktop. You can directly transfer files from your computer, but you can also use Globus file transfer, which I'm going to test out. Now, if you're in the Globus section earlier, you can just search, and we have this UBC ARC Bootcamp collection. If you weren't in this session, you can just follow along, but you might have actual data that you can do. I have my account down here, Nick Rockland, and I have the FRDR demo set up just so you can see what's in it. It's nothing crazy, but I have that README prepended with an underscore. If there's a lot of files, it'll come at the top, CSV file, as well as a small Python code. Now, I want to deposit this whole demo into FRDR. So I can go ahead and press start. Boom. Transfer request successful. Globus doing its thing. It's beautiful. Now you can check your activity here. It's showing you, see it's already completed, but it does give you a good history. If it's a long transfer, it'll show you how it's going. But if we go here, you can see succeeded. I have transferred data into FRDR. The deposit's good. So I can plow forward, click continue. Now you can verify your data set, making sure everything is all good. They've minted a DOI. Obviously, this is a demo DOI, but you now have it so you can share it with your work, put it into your publication so they are related. You know, taking a look at everything. It's good, it's good, it's good. And then saying, yeah, I'm finished. I'm done. I want to deposit this. Kapow! Get it in there. And then we wait. That's what's fun. Submission completed. And so if I do return to my dashboard, you can see here, I've just submitted this and we are all good. Now, that's it. That is the end of this part of the session. And so, like I said, I'm not going to go on any further. I'm going to stop sharing. If there's any questions, happy to answer them, but also just tremendously appreciative and thankful to all of you again for sticking this through it. Again, Friday afternoon, long weekend. A lot of you have been here for the whole week. Please do give that feedback to us. This is the first time that we've run a really comprehensive workshop like this with 16 hours of instruction. And so, you know, this is a good starting point for us, but there's definitely things that we can improve upon, that we could tweak. So please, any feedback you have for us is much appreciated. And yeah, happy Thanksgiving, happy long weekend, and yeah, that's it. Have a good weekend, everybody.